Good morning, everybody. Hopefully the last podcast went very well. This is going to be our second podcast in Chapter 12. And here we're going to be doing the Type 2 compounds. And all that means is metals that can form two or more cations. Remember, the cations are the ones that have the positive charge. When you take a look at your cation and anion sheet, you have the cations are all positive on one side and the anions are negative on the other. And so the reason that they have more than one possibility for a charge is that the transition metals, they simply have more electrons, and because of that, they have different configurations that are able to reach stability. So the transition metals can lose different amounts of electrons to reach the stability. And remember, we're trying to reach the stability like the noble gases. Okay, remember the transition metals are the ones that kind of drop through the chart. They're the ones that are a little bit lower, and they have a variety of charges. So you can see all of them on your gold sheet that there's some that have more than one type: copper 1, copper 2, lead 2, lead 4. There's a variety, iron 2, iron 3. So we just have to use a little bit more of a naming system than what we did with just the type 1 compounds. So you're not going to change your approach. We're going to take a look, and I'm going to look on my gold sheet. I'm going to see that it's iron 2. So it's telling me, the Roman numeral there tells me which charge it is and which cation is forming. And then oxide is oxide, SO minus 2. We're still trying to do the same thing where we want to have our compounds balanced. So you can see that plus 2 added to negative 2 is going to be 0. So I don't need to do any crisscrossing. I don't need to have any subscripts. And my formula is just going to be FeO. Okay, let's try one that we do need to crisscross. If we take a look at lead 4. So again, lead is one of those transition metals. The Roman numeral 4 here tells you what charge it is. And I look up bromide, and that's Br minus 1. Now I can do my math, and I can see that plus 4 and minus 1 do not equal 0. So I'm simply just going to crisscross my numbers. The 4 is going to drop down here, and the 1 is going to drop down here, and I am going to get Pb. For every 1 lead 4, I need 4 bromine to satisfy this compound. And again, if I look at my math, it works. Positive 4, negative 4. So I simply just need to crisscross my numbers, and I'm going to get the formula. Now this part is usually pretty simple for students. It's the next part of trying to figure out which transition metal I'm actually using. So I'm going to do the work down here for number 3. And we have Fe2O3. So the first thing that I like to do, especially when you're starting out, is I like to separate the cation from the anion and get all the charges that I can. So if I look up iron, I have a choice of plus 2 and plus 3. Those are the two irons that are common for iron. I look up O, or oxygen, for oxide, and it's negative 2. So I still want to do my math. So if I take a look, I have 3 multiplied by negative 2. So this half is negative 6. And remember, we're trying to equal 0. So if I do the same multiplication over here, plus 3 times 2 is positive 6. 2 times 2 is 4. That's not going to equal 0. So it has to be iron 3. That gives me my plus 6. So when I write this out, I have to use a Roman numeral. So it's going to be iron 3 oxide. Okay? I know, a little bit confusing. Let's try another one, number 4. So we have PbS2. Remember, the little trick is divide it cation to anion and then write down all the charges. So lead has either a charge of plus 2 or plus 4. Sulfur is minus 2. So when I do my math, 2 times negative 2 is negative 4. I have to have that equal to 0. Well, it's understood right here that this lead is a 1. There's not a subscript there, so it's 1. Well, is 1 times 2 to plug in here equal to 0, or 1 times 4? Hopefully you're saying 1 times 4 equals 4, and that's going to equal 0, so I have to have lead 4. Again, use your Roman numerals. So lead, 4, not sulfur, it's sulfide. Okay, and that's the naming system they're using the transition metals. Now, sometimes you're going to see some new and old naming systems here. The old system that they used to use before we got a bunch more elements in there and it got too difficult is that for the lower charge, you would have OUS to the element with the root name, and for the higher charge, you would add IC. So for instance, instead of lead 2, you would say plumbus. Instead of lead 4, you would say plumbic. So if I'm going to say iron with its 2 charges, the top one here is the lower charge, so that's going to be ferrous, and then this is the higher charge, so this is going to be ferric. So you can see the OUS and the IC. Sometimes you'll see that. Our new system, I think, is a little bit cleaner. You can see that it just gives you the charge and it gives you the Roman numeral to represent that. Okay, so I'd like you to go ahead and try these practice problems, and you can check those in class along with homework number 2 for the second naming system. Have a great day and keep working hard.